Okay, week 10 of the semester. We are getting close, the last third of the semester. We're back to running. So remember what we're doing is we're cycling through the three sports, swim, bike, run, and we are on the second round of doing running. And we'll do one more round of running because I have some follow-up information I want to give you for even the material that I present here in this week. So this time of the semester, I really try to focus more in application than nuts and bolts. And so you'll see that in the videos listed here. I have a lot of time loaded into this week, but these presentations are easier to watch. They're much more application of biomechanics and actually integration of biomechanics with other areas of exercise science and kinesiology to really understand human performance. So you'll see a blending of information here, and I even do that in these first three lectures where I talk about energetics and locomotion. And for energetics and locomotion, I really start by zeroing in on the physiology, going from chemical to mechanical energy. The last round of presentations I'll do for running will be more heavily on the mechanics of energy. And I'll do that, I think that's 10, 11, I think I'll do it in 12, week 12. So you'll get two rounds of of cost of locomotion. I do a little bit of mechanics in this one, but it mostly is an overview of how to start using the term power relative to energetics of locomotion. And again, locomotion, I'm focused in on running here as opposed to walking, skipping, hopping, or sideways locomotion. All those are viable forms of locomotion, but we're zeroing in on running. So these first three presentations are sort of the nuts and bolts information for the week. The next five presentations are really application and really trying to start putting our biomechanics in motion to understand running. So I have a presentation here I did for the I'm trying to remember ICSK, but Students of Kinesiology International Conference for Students in Kinesiology. I did a presentation on physics and physiology of sport, focusing in on swim, bike, and run. And again, I blend the physiology and mechanics in that presentation, plus a little bit of motor control, motor coordination. And I talk about why we run the way we run. That's a very, that's a presentation that I really like that question. And it doesn't necessarily have any application, but it's more for sort of theory of doing research and why we sometimes just ask questions that are interesting. And then I have a glute activation for endurance athletes there. That's with Ted Gerard and myself. And this is where Ted Gerard, with his clinical experience, really talks about the importance of anatomy and muscle activation during running. And so some real neat practical guidelines and tips for trying to stay injury free. Then you've got running stride frequency, why it matters and why it does not. That's again a conversation with Ted Gerard and myself. And here we cover a wide range of areas related to stride frequency. And I think that's sort of a fun conversation that the two of us had on running stride frequency. And then finally, one more conversation with Ted and myself, running a faster 5K. So now we're trying to put things in motion again. We're trying to actually take the research that we do and start applying it to running and how to run faster in this case. Now, there's other ways to approach running. We could approach running how to run farther, how to do an ultra marathon or a marathon or 100-mile race, something like that. That can lead us to a little different conversation in terms of mechanics and physiology to be able to do that. But in this case, we decided to focus mostly in on running a 5K. Okay, so watch those videos. And again, the ones in gray are really application, and you're listening for the biomechanic terms. And I highly encourage you to be writing the terms down as you watch them, so you can go back and make sure that you can define them. Can you clearly define stride frequency in this case, or stride length, things like that. So really be listening to these for terms that you need to know. I'm going to go through this in a little bit more. This for the project, what I decided to do was actually give you a practice on kinetic analysis. Okay, so I'm going to stop sharing this one, and I'm going to share this one. But what is really key to understanding swim, bike, and run from a biomechanics perspective is to be able to do a kinetic analysis. So what I want you to do, and I'm not going to grade these in terms of a percentage. Okay, this is, again, you're going to do these and it's going to be done. And then I'll add some comments later on about what was right and what was wrong for the group. So you're going to identify forces acting on the swimmer. You're going to list those forces right here. And then you're going to write out the equation for horizontal motion. How do you go horizontally in the swim? If you can't draw the arrows on the swimmer, and you can play around with the different, there are some different inserts here that you can do to add, oh, now I'm doing drawing. Let's see if I go under, oh, I'm drawing a blank on to where my symbols are in here, but I can find the arrows up in the Word and add them down here. Don't worry about adding the arrows, okay? If you can't add them, okay, that's secondary to identifying the forces and then writing out the equations for horizontal motion. Also do biking uphill, okay? And do horizontal motion, or the motion of biking up the hill, not horizontal relative to flat earth. And then do running as well, identify the forces. And then I want you to do two equations, one for horizontal motion and one for vertical motion. Just get in a mindset of biomechanics of these three sports. And I think that will be helpful. All right, so that's it for this week. Again, we're moving heavy into application. So there's more hours in video watch there. And the energetic cost of locomotion is an interesting area that launches us into some different areas. I'll follow that up with some more mechanics in week, I think I'm doing it in week 12. So I think that's it for now. I will later this week be posting a summary of the exam 2, where people did well and where, which questions people may have struggled with. And I'll post a review of that later this week in an announcement. Okay, I think that's it for week 10, last third of the semester. Let's keep up the good pace. Okay, thanks everybody.